The time is 9 o'clock.
Thank you very much. Good morning, everybody. Let's continue our discussion from last time. We started looking at an overview about multicasting. We looked at the difference between multicasting and multiple unicasting. In a multiple unicasting, the source will make multiple copies for each individual for each individual group member, whereas in multicasting, the source will only generate packet, and the routers along the way will generate what is known as a distribution tree, where they will make copies on a needed basis. They will make copies of the packet only on a per needed basis. So it results in the reduction on the number of packets that are flowing through the network and saving some bandwidth and eliminating the need to have multiple copies made by the source. We said that we are going to be looking at, as we move along, is how to identify a multicast group, how to leave one, do they need to know about each other, and so these questions. The most important to us is that how do the routers interoperate with each other to multicast packets. Just like in the case of what? Just like in the case of a unicast, advertise to the rest of the internet, which network can he reach. In the case of the multicast, advertise whether there are interest in the leaf networks. These are called leaf networks. It is attached to multiple networks. Each one of them is called a leaf network. This one, leaf network. So the router will advertise to it or to the rest of the internet whether there are interests in receiving certain groups. So for example, this leaf network, there are interests in receiving multicast address to group 1. And this network there are hosts who are interested in receiving a multicast address to group 2 and these things. Okay. Now, the three elements of multicasting, or the three multicasts, is the following. First of all, the multicast addressing. We said that the multicast addressing is the 4.0.0.0/4. That's why, because the block starts with what? This is the block. Starts with, so the multicast group address starts with what? 1110, and then 1. There are what? 28 bits long. This is the multicast group. This is the prefix. So the address is what? 20.0.0.0/what? 4. This block is 2 to the what? 28. The size of this block, the 2 to the 28. Why it is 2 to 28? Because the prefix is only 4. There are 28 bits addresses, by the way. Some addresses are for specific cases. 224.0.0/what? 24. What does this mean? When I say 224.0.024/24, what does it mean? I.e., 224.0.0 all the way to what? To what? When I say /24, all the way to what? 224.0.0.255. This is what the 24 bits, the prefix are these. 224.0.what? 224.0.0. The last bit is the only are reserved for local multicast. Local multicast on the local net. They are reserved on the local. Then we went and see the mapping from an IP multi to a link layer, say Ethernet, address. What does this mean? Let's assume that we do have a router here attached to a what? To an Ethernet host, and the router is receiving a broadcast packet. And there is G1 and G1. This multicast packet is a what? Source G1. Coming from a certain source, and it addressed to what? To all group members. What does this one do? What the router will encapsulate the IP multicast multicast packet, a frame, an Ethernet frame, with a multicast MAC address. Multicast MAC address. In other words, this router will take this packet and put it in, and the destination MAC address is a what? Is a multicast MAC address. The mapping is what? The mapping. Assume just an example. This is 1110. This is the what? 28-bit. It's multicast address. He will map it. Now in the frame, the Ethernet is how many bits long? 48 bits long. The Ethernet is what? 0105E. Each one of them is in hexadecimal. How many bits so far? How many bits so far? This is a hexadecimal. 24 bits. 4 bits. 4 bits, 4 bits, 4 bits, 4 bits, 4 bits, 4 bits, 24 bits. And then what? 0. These are 23 bits. The first 23 bits here. So this is, which means what? 5 not used. Out of 28 bits are not mapped. 5 bits are not mapped. The first 23 are mapped, and this one is spent. The total is how many? Total is 48 bits. Clear? So once the network interface card recognizes this addresses, then address. Now this implies what, by the way? This implies that there are 2 to the 5 multicast group addresses multicast MAC multicast MAC address. The 5 is because 5 bits are what? 5 bits are not mapped into the multicast MAC address. Clear? Clear? Okay, this is all from last time. Quick review from last time. Then we started with what? We started looking at the next one, which is the Internet Group Membership or Management Protocol. That's the second part of multicasting. I called what? Internet Group Management Protocol. Let's review it quickly. This again from last time. The first thing, it's a local protocol. Local protocol means what? Its effect is only on the local network. Okay, implemented. Host and on same network. Let's take an example so that you understand what I'm talking about. This is a router. This is the what? These are the hosts. A, B, C, D, and so on. So all of them, including the router. This is from upstream, coming from upstream. All of them, including the router, they implement what? Internet Group Management Protocol. And what was the purpose of this protocol? The purpose of this protocol is to figure out whether there are any interest in joining joining a certain okay, some messages, by the way, IGMP went through versions. Each version, of course, adds some new messages in it. The first one is called what? QoS messages. QoS messages, what? This router periodically will send a what message? Either for what? Either for specific group or general multicast group. Specific multicast group means what? Means this one will be sending what? Will be a message saying what? Is there anybody interested in receiving this multicast group? Is there anybody? Why is he is asking that question? Because if there are no interest in receiving any multicast traffic, this one upper or upstream routers that I don't need what? You don't need to make copies for me. There is no interest in receiving group. There is no interest in receiving this multicast group. Don't include me in your what? In your attribution tree, which I'll show you in just a second. So he will send a query message. This is, for example, is the query message. The query message is telling what is the version of the IGMP. The message here, maximum response time. The router will set up a maximum response time, expecting that all the hosts in the same network, on the same local area network, to respond within this certain. This is the checksum, and this is the multicast group address. The multicast group address. So he is for a specific multicast group address. He is asking if when the host receives it, when all of these hosts receives it, what will they do? They will what? Each one of them will choose a random number between 0 and what? And the maximum response time. And the maximum response time. Okay, so let's assume the maximum response time was what? 10. Choose what? 5. The other one will choose 8, and so on and so forth. By the time your counter, the host whose time has expired will send a report. So the host interested in the multicast group, a host will send a message for that. Back to what? Back to the router. Okay, all other hosts interested in receiving the multicast group will suppress their what? Will suppress their reports. Suppress their reports means what? They will not send reports. What is enough? The router is not interested in how many hosts want to join a multicast group. They're interested in what? In knowing, is there an interest in that multicast group? So the router attached router does not care about what? Does not care about which or how many a given multicast group. It only cares whether one or more of its attached hosts belong to the group. Clear? So when they see, let's assume this one send the query, when one of the report, When all of them see the report, they will not send a report of their own. They will not own. Why? The router is not interested in receiving many reports. He is only interested in figuring out what. In here, interested in receiving this multicast group. So they will suppress their report. Okay, note. A host could be members. It could be, member of many multicast groups, many multicast needs a report, a separate report for each one. You cannot group it all in what? In one report. You need a report. It's like a lab. You need to submit the lab a report for each individual lab. You cannot just group it all. You get this or not? For each one of them, you need a separate multicast group. Clear? Okay. Now, notice, by the way, note routers, the leaf router, do not need the rest directly. It is configured to process all multicast packets. What does this mean? It means that when this one respond to the inquiry, the response does not need to be what? A unicast to the router. A unicast to the router. Why is that? Because the router is configured to read any multicast, configured to read any traffic, which is a multicast traffic. Any multicast address is configured to what? To process it. So when this one responds, the response will not be what to the router. It will also be what? Multicasted. Allowing what? Allowing the host to suppress their reports. Clear? How come nobody asked, how would this one see the report? How do these hosts see the report? How do they see the report? When this one is sending the report back, how do they see the report? Nobody asked that question, or nobody even thought about that question. How do they? This one here, the reply to the inquiry is unicasted. It is also what? Multicasted. So when they are interested in receiving a group, they will what? They will see the report here and they will suppress their own reports. The routers is already configured to read any traffic associated, does not have to be addressed to what? To it individually. Okay. Also allows hosts to join multicast group without having to wait for an inquiry. From router. They include, this is in later version P, they allowed a host to join a multicast group rather than waiting for what? A query message from the router. So for example, if this one is interested in receiving multi-packets, he will what? He will send a join message to the router telling him what? This multicast group. He does not have to wait for an inquiry. IGMP also allows host a specific. What does that mean? This host decided he wants to leave the multicast group. What will he send? A leave message. He will send a leave message telling the router, I want to leave what? I want to leave this multicast group. Clear? Upon receiving a leave message, routers immediately send a query message. Why? For that, specific group. Why? Why he will send in other words, when he's sending a leave message for a specific multicast group, immediately send a query message for that same multicast group to figure out if there are any remaining hosts which are interested in receiving the multicast group. Remember, the router does not know he received how many reports. He received only one report. Have what? Suppress their reports. So when one of the hosts send a host, he will immediately send a query. There are remaining what? Remaining hosts clear network that are interested in joining the multicast. Clear? Okay. Send a query message to find if there are any hosts remaining interested in receiving this multicast group. IGMP also allows to specify from source he is willing to receive packets. What does that mean? What GMP also allows a host to specify from which source he is willing to receive multicast packets. That we do have a what? A multicast group, and it's many to many, which means what? There are multiple sources. I'll tell the router, I am interested in group. I am interested in this multicast group, but I'm only willing to receive what? Willing to receive packets from a given what? Source. I am not interested in receiving packets from what? I'm only interested in receiving what? Multicast group packets from what? That individual. IGMP allows the source, allow the host to tell that to the router. So the routers, all of these routers, what? The source IP address. If the source IP address is the one that this one is not from, then they will not make copies for what? They will not make copies on this leaf network. The whole idea is to try to reduce the amount of traffic, that is traversing through the clear. Okay. So this is briefly the IGMP. We discussed it last time. This is just the query messages and the IGMP messages, so on and so forth. Now, the next component is establishing this next component of multicasting is establishing known as a delivery cast tree. A delivery multicast tree consists of what? Consisting of branches, its routers leading to interested network, interested destination networks or leaf networks. The trees, like we saw last time, the trees can be to a source-based tree, a tree. In here, different trees are created depending on source, on each source. This we designated by what? SG. So for a given source and for a group. So if there are, for example, n sources, how many trees do we need? We need any trace, or one for each one for each source. In here, a single tree is shared among all group members. We designate this by a wildcard, and then what? G. This is called the wildcard. A single tree, which is shared among all group members. So if you see, for example, if you see this is a source tree. This is a source tree. The source being A to here, I will send it to here. This one, these are all routers. These are all routers. This router is attached to where the source host is located. So this one will make a copy here, 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 here. In this case here, who is the source? The source is D. So he sent what? He sent it here, 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 and so on and so forth. Here, for every individual source, you need a what? You need a tree. We'll see that in just a second. Okay. Then we went into the used the algorithm by multicast protocols to create the delivery or the multicast tree. These are algorithm cast routing protocols to create the tree. The first one and the simplest one is called what? What does that mean? Flooding. In a flooding, every router receiving a multicast group packet will flood packet to all its interfaces, to all of its interfaces except, of course, the one that the multicast packet arrived from the following. If we do have a router in here, he receives a what? A packet, a multicast packet, then here, here, and here. Clear? Flooded, flooded. Here, here, here. As long as he has not seen this packet before. What does that mean? As long as he has not seen this packet before. What does that mean when I say as long as he has not seen this packet? See, this one here, let's assume there's the multicast router. Now let's assume there is a what? This one is connected to another router, R1, R2. This one is connected to another E. Now let's assume that this one is like this and so on. So this one here, when he will flood it to all its interfaces. When this one here comes to this one, he will flood it to all his. When this one receives, he will remember that he received what? This packet before. Are you following me? So he will then what? He will just ignore it. In other words, every router will flood with only what? Only once. Are you only once? Because they are going to be keeping track of what? Keeping track of the whether they have seen the packets before or not. Do routers in this case here needs to keep track of needs to have routing tables? Do they need to have routing tables in this case? In the flooding case, do they need to have multicast routing tables? They don't need to have multicast routing tables. Are you following? They don't need to keep track of those. All what they need is what? Whether they have seen the packet before or not. If they have seen the packet before, then they are not going to continue with the flooding. Clear? But if they have not seen it, they will what? Flood it. Are you following? So this one is easy, but generates a whole lot of traffic. So which means what? Not scalable over not scalable of a wide. Okay, the second one is called tree. Here, there is one path between two routers. There is only one path between any two routers, i.e. no what? No loops. Clear? And route will only forward multicast group packets over that are part the spanning tree. Will forward the packets only over the branches that are what? That are part of the spanning. Clear? Okay. Spanning trees, by the way, this is again a simple algorithm, but may result in some branches being what? Unutilized. In other words, inefficient. Use bandwidth may also result in suboptimum trees. Suboptimum trees means from what? From a source to a destination, you are going to go through a tree, which is not a what? Which is will provide for minimum delay, for example. Clear minimum delay, because it's longer than the others. Some of them are what? In other words, if you do have like this, let's assume that you do have like this, a whole. Okay, is the one that is attached to source, you are going to what? You are going to have one path, every router and every other router. Let's assume this is the spanning tree. What does that mean? What does that result in? Trees branches are what? All of these are not utilized. Are you following? Because they are not part of the what? They are not part of the spanning tree. Clear? Okay. Then they on what? So this number 3, reverse path broadcasting. Let's see if you can, this is a router. Are its ports. This is called the parent or port. This is along the way the shortest path back to the source. In other words, there is a source, a multicast group source setting. This one is pointing toward what? Is pointing toward the shortest path back to the source. These are called what? Child interfaces. A router will forward a multicast group packet if it arrives from an interface, from a parent interface only will and a multicast group packet only if it arrives from a what? A parent interface. We multicast group for a specific source. If a multicast packet comes from a child interface, he will not what? He will not forward it. Clear? Okay. So for example, let's assume I have the following. This is the source. Okay, let's assume this is R1. Or what? Leaf networks. And let's assume there is a what? Is a group here. G1. This is the S G1. This is the source. Now he will send it to the router. Router, he receives it from the parent interface. He will send it to what? Here, and he will send like this. He will send it what? Like this. He will send it to here. He will send it to here. Do. What will this one do? Did he receive the packet from the parent port? He receives the port. What will he send it? He will send it to here, and he will send it to here. Now, listen to me. This guy. Will he send it to this guy? Now, listen to this. Routing. In unicast routing, which is what? Which is laying below the what? The multicast routing. The multicast routing over the unicast routing. If R3, if R3 knows that it is now along the shortest path between R3 and what? R1. He will this link on this branch. Excuse me. You didn't get this. Concentrate. How does R3 reaches S? Let's assume unicast packet, unicast routing. If R3 receives a packet, a unicast address to this source, what is the next up router? What is the next up router? R3. Our next up router, if he receives a unicast packet destined to S, he will go. If this one knows this fact, if R2 knows that R1 next up router from what? R3 back to the source, he will not send this branch. Why he will not send it? Because he knows that if he sends the packet on this, R3 will what? Drop it. Did you get my point or not? Why? Because it's not the next up router from where? R3 back to the source. Are you following me or not? You didn't get it. Get it? No, you didn't. No, I can't. Okay. One more time. Let's try it one more time. Unicast routing. Like what? Like OSPF or what? Or distance vector. If I use a packet from where? I don't care from where. And is destined to who? To the source. What is the next? R1. Are you following me on that? If R2 knows this fact, how does he know this fact? How does R2 knows this fact? Underlying unicast routing protocol is OSPF. Then you know from OSPF knows the map. Yes? You remember this from 450. Every router knows the map. He knows that R2 is not the next up router from who? 3 back to who? Back to the source. The next up router is what? Is R1. So he will not send the packet. If he does not know this fact, will he send the packet here? Yes, he will. What will he will drop it? Why? Because it came from a what? An interface which is not interface leading from where? From R3 back to the what? Back to the source. Parent interface of this one is the parent, because what? The next up router along the what? The shortest path back to the source is what? Is R1. Please not send it to him. He will not send it to him. By the way, will this here? He will not send it to here because R2 knows, sorry, R3 knows that R2 is next hop router. R3 knows that it's not the next hop router of R2 back to the source. The next hop, the previous hop is what is R1. So neither this one send it to this nor this one send it. Clear? Okay. How about this one? How about this one? Will this one? He received the packet from here. Yes? Will he send it here? Will he send it here? If this R3 knows, what is this? Let's put them number. R4, R5, R6. What is the next hop? What is the next hop router from R5 back to the source? If it happens to be R2, if it happens to be R2, and R3 knows this, then he will not send the packet here. Why he will not? Why will not send it here? Because if he send it here, R5 will receive it from a what? Failed interface, and hence he will what? He will drop it from its what? From he will not forward down streams. Clear? Okay, good. Note by the way, and by the way, once it reaches this, so this, let's assume this one, send it to here. Send it to here. This here, here, here. No, notice by the way, reverse, reverse. Do you understand why they call it reverse? Why do they call it reverse? It's first of all reverse path broadcasting. Take into account or does not include include IGMP in a delivery tree. What does that mean? What does that mean? Listen to this. Let's interesting here. There were nobody in here is interested in. Let me ask a question. Did this one forward the packet here? When R3 receives the packet from a parent interface, did he forward it to R6? He forwarded to R6. You know what? There was no interest in here, but he still what? Forwarded to what? Why? Because reverse path broadcasting does not take into account IGMP tree. He does not take IGMP into account in creating the tree. So even if, was there a reason for this to make to forward the copy here? Was there a reason to forward a copy of the packet to here? No, there was no reason. Why? Because there was no host here interested in receiving this multicast group. Did you get my point? Or send it anyway. He sent it anyway. Why? Because in reverse path broadcasting, does not take into account IGMP in what? In setting up the tree. Clear? So it resulted in what? It resulted of unnecessary traffic. That is what? That is being sent. Okay. It into what? Into the reverse path multicasting. Reverse path multicasting, RPM. This is also what is known as flood and what? Prune. Flood and prune. Let's take an example so that you understand what I'm talking about. Again, this is connected to this source. Okay, this is the leaf network, and there is G1. There is an interest in here. This one, network, no interest here, and this is no interest in here. group members, no group members. And let's assume this is the tree that was used for the first few packets. Let me ask you a question here. Who is the short router? Who is the next hop router from R5 back to the source? 3. Are you following or not? This R3 is not this one in this example. Clear? So let's see if you can help me with the algorithm here. At the beginning, for the first packet, he receives the packet from this. Okay. Receive the packet. The packet is what? S, G. He will send it to here. Here. Yes? What will this one do? He will send it to here. He send it to here. At the beginning. At the beginning. At the beginning. The flooding. That's why we say prone. He will send. He will send it to what? Here. He will send it to here. He will send it to here. He will send it to here. All of them. Notice, by the way, once this one, flooding, once this one receives this one, he will not flood it again because he will remember that he has seen this packet before. Clear? Clear? Okay, and then he will send it here, here, and here. There is no interest in here. There is no interest in receiving the multicast group here. What will this one send back? What will this one send back? He will send a pruning message. Clear? Okay. This one, by the way, will not send it to here. He will send it to here. This one, a pruning message. What will happen? When this one send a pruning message, R4 send a pruning message to R2, what is he telling it? R4 is telling R2, I don't want you to send me packets belonging to this multicast group on this child. This is the child interface as far as who is concerned. Who is concerned? This is the child interface as far as who is concerned. As far as R2 is concerned. He is telling him, do not any packets in here. This one will what? Will disable that interface here. In other words, if he receives, he will not send it to this. Yes? Okay. He will send, by the way, interest here. This one will forward what? Pruning message to this guy. Why? Why is he sending the pruning message to this guy? There is no interest on this side. Clear? This one will send a pruning message to here. There is no interest in here. But will this one send a pruning message? No, he will not. Which means what? Will this one send a pruning? No. So what do you end up with? What tree do you end up with? You will end up with this tree. This is the final. Only 2 branches. This or not? Did you get this or not? Hey, only 2 branches. Why? Because you send what? You send upstream to your what? To your routers. A router, by the way. A router. A pruning message. To an upstream router, to an upstream router through which interface? Say to an upstream router through which interface? Through the parent interface. Only if it what? It receives pruning messages from all its downstream routers. Through who? Through which interfaces? through child. Clear? Clear? Okay, this one here. See this one? Send a pruning message to here. It receives a pruning from the child interface. It receives a pruning message. R3 receives a pruning message from what? Will he forward it to R1? He will not forward it to R1. Why? Because he did not receive a pruning other child interface. Did you get this or not? He did not receive a pruning message from this other child and not forward the pruning message. Clear? Did this one forward the pruning message? He did. He received what? A pruning message from its what? Child interface? Yes, from this guy. There is not a part of the tree. Did you get this or not? This is not part of the tree. Why? One is the what? Excuse me. This is the router along the shortest path back to the what? Does not receive anything from here. He will what? Forward the pruning message to this. Clear? What if this one tried to join? What if this one, another host, tried to join a group? What does that tell you? It tells you that the pruning message to what? The pruning messages needs to be what? Periodically? Yes? Pruning messages.
The time is 10 o'clock.
It needs to be periodically refreshed just in case. New host. The multicast group. Which means what? Periodic. The algorithm goes into what does that mean? What does that mean when I say periodically the algorithm goes into the flooding mode? What does it mean? Remember what did we started? We said flood and what? Prune. So at the beginning, you packets. Are you following or not? Waiting for what? Pruning message to come back. Yes? Okay, some branches. Then what is it? Periodically, you are going to repeat the flooding. Just in case what? Just in case a new host has joined the group. Clear? Now, to prevent this from keeping happening, okay, they also used what is known as crafting. What is the meaning of the word crafting? Anybody? English? No? You haven't seen this word before? Crafting means what? What is pruning means? Crafting means what? Putting it back. Crafting is the opposite of what? Pruning. Which means this one sent a pruning message to this one. Yes? Because there were no interest. So is what? Suddenly a host send a join to that group to the router, R4. 4 will what? Will send a crafting message to what? R2. Which means what? What is it? What is R4? It's telling it. Telling it this branch is back to being part of the what? Of erase the what? Erase the pruning message that, or ignore the pruning message that I sent. There is a host interested in receiving this multicast group. Clear? Clear? Can you also use crafting to what? To re-establish a pruned branch. Now, next, share tree. What is known as what? Core-based tree. Okay, all previous algorithms are for shared, for source-based tree. Source-based, let's understand the shared tree. Okay, let's assume that I have R1 here. R3, R5. Okay, and let's say there is a source here. Yes. So there is, oh, I'm sorry, R6. Sorry. What are these? Yes, what are they? We have a group, a multicast group. Any one of them could be what? Be the source. Now, remember, in a shared tree, all the sources, all multicast group members share same tree. All of them share the same tree. Now, let's see how it works here. Here, say R4 is chosen as a router or as root or rendezvous point. RP, rendezvous point. Rendezvous means what? Where the rendezvous is what? Is a space or is a place where everybody what? Where everybody meets. Are you following what? Say what we say? It's a rendezvous point. Okay. Now let's see how it works. This S what wants to join a multicast group. This host. Let's call it A, B, C. All of them wants to join a multicast group. Host A will send packet to the rendezvous point, which is what? Router, R4, a unicast packet. What does unicast? What is the unicast packet means? Unicast packet means what? It's addressed to the what? That packet is addressed to R4. He will send it. He will send a unicast join packet to the RP router R4 through who? Through R3. Through R3. So he is going to send a what? A join. What is he joining? What is he joining? He is joining this. Clear? He is joining this group. Router. When R3 receives this join message, when R3 receives this, he will what? He will forward it. Let's assume this one. He will forward it. First of all, this. He will remember that he received a join message on this interface, which means what? This part of the what? Part of the tree, he will forward the join, and this becomes what? A part of the tree. Did you get this or not? Okay. Now, B wants to send a join message. Wants to send a join message. What does R3 do? Does he forward the join message or not? Star G. Does he send it to here or not? Does R3 send it to here or not? No, he does not. Why? This R3 already remembers that it has sent a join message for the same group. So all what he needs to know is what? This becomes what? Just like he does not repeat the join message here. Why? Because it's for the same what? For the same group. Okay. Now this one send the join message. What does this one do? He relay it to what? Here. This becomes part of the tree. Clear? So where is the tree now? Where is the tree? If this one is sending, how does it go? If this one is sending, follow me. This one, make a copy, send it to here, here, here. Yes? If this one is sending, how does it go? Is it the same tree? Is it the same tree? It is the same tree. No. Whether this one is sending or whether this one is sending. How does it go? Here, then what? You get it or not? All what? All sources, all group members, multicast group members share the same what? Share the same tree. Clear? Oh, summarize this one more time. Every what? Every host who is interested in receiving a what does he do? He unicast, not multicast, unicast a packet to the rendezvous point or to the core router. He telling it what? In what? I need to join that multicast group. Clear? Every time this join message goes, intermediate routers along the way, the intermediate routers, they remember or they save, they put it in their memory that this interface became part of the what? Part of the tree. Clear? They forward those intermediate routers, they forward what? They forward the join messages all the way to core. And every time it goes through a branch, the branch becomes what? Part of the tree. Clever host wants to join for the same group, and an intermediate router already has its memory, that core point, that rendezvous point to that multicast group. He will not force again. There is no need to do that. Clear? There is no need to do that. It's already part of the tree. The branch is already part of the tree when he send the join for this guy. What if there's a host here? What if there is a host here? What will do? What if is interested in that group? What will he send? A join message? And here, this one is sending, this is the leaf router. So in here, what is he using? He is using IGMP. Did you get this or not? This is the leaf network. He is sending IGMP. Yes? This route unicasted to here. Join. This becomes what? Part of the tree. Clear? Okay. Shared base tree are more scalable than source-based tree, source-based tree in the sense each multicast group needs only to keep track of rather than what? Thank you. Rather than S comma what? G. In the case of us, every router needs to keep track of what? Where is the source? Where is the source located? So that what? Where is the shortest distance back to the source? In here, they only need to what? They only need to keep track of the, they don't need to keep track of the what? Of the source. Clear? Because it's regardless of the source, all of them will share. However, it might result in concentration of traffic near the what? Near the rendezvous point, and also may in suboptimum might result in what? In suboptimum trees between host, multicast, host, and or point. Clear? Okay. Now, what? These, the above, were summaries of multicast algorithm. They are used multicast routing. They are used in multi-circles. So, for example, we have this multicast distance vector, DVMRP, which uses what? Which uses, are you following on now? So, let's look at each one of them. This is the source space tree stands, examples of a source space tree. MOSPF for what? Multicast. Open. Shortest path first. MRP stands for what? Distance vector. Distance vector, a multicast. DVMRP. What are we comparing it in the unicast? Distance vector. Well, what's between this one and the distance vector and the unicast? Let's see if you can tell me. What in this one and the distance vector in the case of what? Unicast. In the case of the unicast, routers are figuring out what? What is the next hop router along the way to the what? In DVMRP, what is each router is interested in? The next router along the path back to who? To the source. In other words, in multi are interested in figuring out what? The source. In unicast, when a router receives a packet, does he care about the source address? In unicast routing, when a router receives a packet, is he interested in the source? No, he is not. In multicasting, when a router receives a packet from a source, he receives a multicast packet from a source. Does he care about the source address? Address. Why? Because he needs to know what? He needs to know what to do with this packet. Did it arrive from the what? A parent interface, or did it arrive from a what? Child interface. So everything in back to who? Back to the source. Whereas in unicasting, everything is distant to the what? Everything is finding the route to the destination. Clear? Okay. Okay. Next time we will survey this and we'll try to understand.